Hello, I'm Jim Flanagan, and welcome to my den. This is the second in a series of lessons entitled Math. What's the use? Imagine that you left the garage light on all night last night. What a shame. Do you know how much money you wasted? Let's find out. Please enjoy. How much does it cost to keep a light on all night? First, we need to ask, does it matter what kind of light we leave on? It turns out, no, it doesn't. An old 40-watt incandescent bulb and a 40-watt fluorescent bulb and a 40-watt LED bulb use the same amount of power. There are several differences, of course. The 40-watt LED will be much brighter than the 40-watt incandescent bulb, and the fluorescent bulb needs a device called a ballast, which uses a good deal of power all by itself. So what is power? In physics, power is defined as the rate at which electrical energy is transferred. Power is measured in watts, to acknowledge the Scottish inventor James Watt. It doesn't take much to use 1 watt, so electrical power is generally quoted in kilowatts. 1 kilowatt equals 1,000 watts. Actually, we don't pay for electrical power per se, but for how long that power is used. So electrical rates are based on the cost per kilowatt hour. A kilowatt hour means that 1 kilowatt, or 1,000 watts, is transferred continuously for a period of 1 hour. Now let's talk about light bulbs. A typical light bulb might be rated at 100 watts. That means it takes 100 watts of electrical power to just light the bulb. Since 1,000 watts equals 1 kilowatt, this means that it takes 0.1 or 1/10 of a kilowatt hour of power to light this bulb. If the lamp is on all evening, say from 6 p.m. to 11 p.m., the light burns for 5 hours. Therefore, you'll be charged for 1/10 of a kilowatt for 5 hours, or 0.1 kilowatts times 5 hours, which equals 0.5 kilowatt hours of electricity. Electrical rates can range greatly. To find your rate, you should look at your electric bill. Here's one example. It may look a little complicated, but all we really need is a supply charge to get a good estimate. Let's round this to $0.11 or 11 cents per kilowatt hour. We used 0.5 kilowatt hours, so leaving this light on for 5 hours cost us 0.5 kilowatt hours times 11 cents per kilowatt hour, which is equal to 5.5 cents. Now I would like to give you a way to do this and several other types of calculations. Changing the problem slightly, we'll start with a 40-watt bulb left on for 8 hours. Now, a quick review. Remember, if we divide something by itself, that fraction is equal to 1. Also remember, if we multiply a number by 1, it doesn't make it bigger or smaller. And finally, take note that in this very specific problem, and according to the electrical company, 11 cents is the same as 1 kilowatt hour. So, 40 watts times 11 cents per 1 kilowatt hour times 1 kilowatt hour over 1,000 watts is the same as 1,000 watts times 8 hours. Note that the second fraction is equal to 1, as is the third. Typically, we write this as a table. You can see this is just 4 fractions being multiplied together. We start by dividing the numerator and denominator by the same units, a process commonly referred to as canceling. So what do we have left? When we multiply fractions, remember that first we multiply the numerators together. Notice that the only units left is cents. 40 times 11 cents times 8 is equal to 3,520 cents. Then we multiply all the denominators together. Notice that there are no units left in the denominator. So 1 times 1,000 times 1 is equal to 1,000. Then we divide the product of the numerators by the product of the denominators, and we get 3,520 divided by 1,000, which is equal to 3.520, or 3.5 cents. So it turns out your one-time only mistake didn't really cost you that much. But let's talk about phone chargers. Turns out that phone and laptop chargers still use electrical power even when the phone or laptop is not plugged in. Numbers vary, but let's say your phone charger uses 5 watts and you leave it in the wall socket every night, every day, 24/7 for a year. Using our table from earlier, 5 watts times 11 cents per 1 kilowatt hour times 1 kilowatt per 1,000 watts times 24 hours per 1 day times 365 days per 1 year is going to get me 4,818 divided by 1,000, and rounding to the nearest cent, that's about $4.82 a year. Notice I changed the cents to dollars and added the last 2 fractions. So if you'd like to save money on electricity, turning off the lights and unplugging the chargers would help, but not nearly as much as buying a smart thermostat or just using less hot water. But if paying even a little bit of money for electricity still bothers you, then I suggest you don't even think about that refrigerator. Here endeth the lesson. Thanks for listening.